Let's discuss question number 31 from test 4. This is from machine design. A square key is given and the side of square key of side d by 4 is fitted on a shaft of diameter d. So you have a shaft and you have the key, and let's say the hub is something, the bigger one. Hub is something like this. Okay, so hub portion I'm not drawing. So this is your shaft and this is your key. Okay, so the shaft is of diameter d. If the material of the key and the shaft is same, okay, so material is same, okay, and two are equally strong in shear. Okay, so equally strong in shear means that the maximum shear stress which key can withstand is equal to the maximum stress for the shaft. Okay, so that's what we need to find out, what is the length of the pulley. Okay, so if I consider, let's say, shaft, and if a torque T is acting on the shaft, okay, the strength of the shaft is governed by your torsional equation, because this torque is resisted by the shear stress throughout the circumference. So the maximum shear stress occurs at the periphery, and this is the torsion equation. So tau max is basically T by J into R, which is the radius, and T is T. J is, for a circular section, it is pi by 32 d power 4. R is d by 2, so this becomes 16 t by pi d cube. This is the maximum stress in a shaft. Now when a torque T is acting, this torque T, okay, is, and when the torque T is acting, okay, so this part acts on this part and this part of the beam. So basically the force, if I consider only the key portion, the force here is basically your the equivalent force because of this torque is basically T by T, because force into D is the moment and this force acts, and the resisting force from the hub is F. So basically it is shear along this plane. Okay, so the shear stress is basically this force by area of cross section of the key. The area of cross section of the key will be basically this area, which is nothing but side A and length L. So F by AL, and F is T by D, A is S, which is D by 4, square key it is given, of length d by 4. So the tau max occurring is d square by 4 L. So because it is equally strong, so these two got to be same. So 16 t by pi d cube is 4 t by d square L, and what is asked is what is L. So t gets cancelled. This is 4 pi d. So this is 16 t 4 d by 2 is your so this is radius actually, because force into radius is your torque. So d by 2 will be your, so F is basically d by 2, because the equivalent force because of this torque applied on the shaft, the equivalent force that acts is force into radius. So this is d by 2 and this becomes 8t and this becomes 8t, and so I get 2 here. So 2 pi d by L. So basically L is pi d by 2. So for the shear stress in the shaft and the key to be equal, the length of the key has to be pi d by 2. So the answer is A. Thank you.